Hello everyone. In the last video, we have discussed about the specific gravity and the mass specific gravity, and how we can write mass specific gravity if it is a dry soil, and if it is a saturated soil, and if it is a partially saturated soil. So now from this video, we will derive the soil water relationships. So one by one formula I will write, and later I'll derive. So in each video one formula I'll derive, like that 12 to 13 formulas will be there. Those are soil water relationships, and these are very important in solving numerical questions, especially from this chapter. So first let me write a formula, and then I will derive. So the first formula will be weight of solids is equal to total weight of the soil by 1 plus water content. So this is what? This is total weight of the soil, total weight of the soil. This is total weight of the soil, and this is water content. This is water content. So now we will derive how this formula came. So if you for example, for deriving, either we should take a left side part or right side part. Just observe what is there in the right side part. So right side part, total weight of the soil is there, and one more thing, water content is there. So for deriving all the formulas, first we should draw the three phase diagram of the soil. So let us draw the three phase diagram. So three phase diagram. So if you see, this is air, this is water, this is solids, that means soil solids. So in the right side we can write weights. So this is the weight of air, which is negligible, which is equal to 0. This is weight of water, this is weight of solids. So this total weight of the soil will be, that is capital W. So that is nothing but this weight of water plus weight of solids. Actually we will be writing weight of air plus weight of water plus weight of solids, but since weight of air is equal to 0, so that is why total weight of the soil is equal to weight of water plus weight of soil solids. So this is total weight. And one more thing, so water content, how we can write water content? Water content is equal to weight of the water to the weight of the solids, weight of the water to the weight of the solids. So let us suppose this is equation 1, and this is equation 2. From equation 2, what we can write? Weight of water is equal to water content into weight of solids. So this is equation 3. Now from equation 1, what is there? Total weight is equal to weight of water plus weight of solids, from equation 1. And total weight is equal to, so in place of weight of water, what we can write? We can write this equation, water content into weight of solids. So water content into weight of solids plus, anyway this weight of solids is there, that as it is I am writing. This is from equation 3. This is from equation 3. So now what we can write? total weight is equal to, we can take weight of solids as common. So if we take weight of solids as common, here water content is remaining, plus since we have taken weight of solids as common, this will be 1 here. So if we rewrite this equation, what we will be getting, weight of solids is equal to total weight by 1 plus water content. So this is the equation, the same equation. This is the first formula. So this is what we have derived. So first what we have taken. So why I am highlighting this three-phase diagram, because uh, if you want to solve any problem in, especially from this chapter, you should know how to draw the three-phase diagram for a given question. So that is why it is very very important. So I have drawn the three-phase diagram, and from that I have framed one equation. So water content definition we know. From that I have taken the first equation, and from that first equation I have derived. So this is as simple as that. So in the next video I'll derive one more formula like this, 12 to 13 relationships I will derive individually. Later that we will solve some numericals. So this is what about this video. Thanks for watching my video. If you like this video, please like and subscribe to my channel. Thank you.